Hi ladies! Welcome to Chapter 4, Section 3, our lesson on mixtures. Now, before we get started, you should have next to you your guided notes that say Chapter 4, Section 3 above. And they should also have your homework on them, like this section review, page 105, numbers 1 through 11, which once we are done here, you can get started on in class. Please make sure that you are ready to also have a separate piece of paper about questions that I may ask during our discussion and questions that you might have when I come back, because this is a time that we don't necessarily get to ask questions or have class discussion. So please keep that blank piece of paper handy. And let's get started. So in section 3 we have mixtures, and next page you're going to see that we have quite a few terms to learn. Mixture, solution, solute, solvent, concentration, solubility, and, if I can move it up, we have suspension and colloid. Okay? These are 1, 2, 3, 4, 5, 6, 7, 8 terms that you really need to know. Okay? They sound very similar, but we're going to decipher them during this lesson. All right? Moving on to our next page is we're going to learn the definition of mixture. Mixture is a combination of two or more substances that are not chemically combined. So that means a mixture is different than a compound. They are not chemically combined. They're just mixed together. Okay? Each substance in a mixture maintains its identity, meaning they don't change. You could separate them out. Just like that, they can be physically separated. And it does not need to be composed of a specific ratio. Compounds are very specific, mixtures are not. Okay. Now we know that we can separate mixtures. Okay, they can be physically separated. So now we need to know how to do so. All right. A first one is distillation. Okay, distillation is a process that separates a mixture based on boiling points. Okay, so for instance, you can separate salt from water because salt and water both have different boiling points. So if you heat them enough, okay, the water will separate from the salt. And that, in other words, is known as desalination. Now, another way that you could separate things is to separate them using a magnet, right? Some metals are magnetic and some metals are not. So, iron is magnetic. Aluminum is not. So you could separate the iron nails by holding a magnet above it from aluminum nails. Another way to separate mixtures is with centrifuge, a machine used to separate mixtures based on densities. Now, a great example for this is separating blood. Now, your blood is made of plasma, platelets, white blood cells, and red blood cells. And what they can do is that all of those things have different densities. So they put it in this machine over here, and it spins it around really fast so that it separates out into layers like the blood that you see on the left. Now remember, ladies, I know that I might be going fast, but you always have the ability to pause the lesson, write things down, and then go back and continue it. Solutions. Okay, we're going to talk a lot about solutions. That's what mixtures are. Okay, the definition of a solution is a homogeneous mixture of two or more substances evenly dispersed throughout. Okay, so what you're talking about salt water. Did any of your parents ever make you gargle with salt water when they thought you were sick to clear up your throat? Okay, that's what a solution would be. There are two parts of a solution. Okay. A solute is in a solution. It is the substance that dissolves in a solvent. So if we talk about salt water again, you have the water, okay, and the salt, or all the solute. The salt is the solute, and it dissolves in the water. Okay, so therefore we need to understand what a solvent is. A solvent is the solution. It is the substance in which the solute dissolves. Okay, now what I want you to do right now is take that blank piece of paper and write a number 1. Okay, under that number 1, I want you to answer this question. Please list 3 solutions that you can think of. They could be anything. You can't use salt water because I just used that one, but any 3 solutions. Okay, pause this video, answer that question, and then continue. Okay, now that you've written down some different solutions, okay, I want you to look at these solutions. I don't know if your solutions that you listed were just liquids yet, but they don't have to just be liquids. For instance, a gas and a gas, right? The air that surrounds us is made up of all different types of gases, okay? Right? We have nitrogen and carbon dioxide and oxygen. All of that is in the air, and that's a mixture. What about a gas and a liquid, like soda, right? You guys all love your Coca-Cola, okay? Soda has bubbles in it, so you have liquid with gas. A liquid in a liquid, a latte, right? Can't you combine those? Okay. What about a solid in a drink? Okay, like drink mixes like Kool-Aid or Gatorade powder or hot chocolate. Solid in solid, excuse me. Brass is a combination of 2 things, zinc and copper. So they're 2 metals that are combined together to make brass. Okay. Now we're going to talk about concentrations in solutions. Okay, concentrations in solutions are very important because it means the amount of solute in the solvent. Okay? So, the definition of concentration is the amount of a particular substance in a given quantity of a mixture, solution, or ore. Okay? It's expressed in grams of solute per milliliter of solvent. So you have grams and you have milliliter. Keep these units in mind. They're very important. Okay? Concentrates may be dilute or concentrated, but does not tell you how much of the solute is dissolved. Now, dilute means if you take salt water, for instance, a dilute salt water would mean that it is very watery. There's not much salt or there's not much solute in it. A concentrated glass of salt water would mean that there is lots and lots of salt in it. But as I can say, it's only a qualitative description, like it only describes it. It's not quantitative. It doesn't tell you exactly how much. Now, we want to talk about solubility, okay? Because solubility it concerns solutions and the amount of solute. Solubility is the ability of one substance to dissolve in another at a given temperature and pressure. Remember, we're back to temperature and pressure. It's very important. Solubility in substances changes with temperature. I want you to keep that in mind. Okay? There are going to be 3 different ways that we're going to talk about to improve the ability of a solvent to dissolve a solute. Okay? You may dissolve substances faster by mixing. Okay, stirring or shaking causes solute particles to spread out more quickly among solvent particles. Okay, so over here on the left, you see this green drink being mixed. Okay, but on the right, you see this being heated. So heating is also important. Remember we talked about temperature? When you heat, particles move faster, and solute particles separate into the solvent. Okay. And lastly, we have crushing. Okay? Crushing is the solute increasing the amount of contact with the solvent, and it mixes more quickly, right? So if you've ever had a pill that you don't want to take or something like that, if your mom crushes it up and puts it in your milk or something, then you can't taste it and it dissolves right in. Now, our last two vocabulary terms are suspension and colloid. A suspension is a mixture in which particles of a material are more or less evenly dispersed throughout the liquid or the gas. Now, particles are large enough to block light, but they're also too large to stay mixed without being shaken or stirred. The best example of it of a suspension is a snow globe. Okay, a snow globe, right? You have to shake it, right? Shake it right here in order for the particles to stay mixed. And eventually they're so big they settle right out to the bottom. And last, okay, is a colloid. Is a mixture consisting of tiny particles that are intermediate in size between those in solutions and those in suspensions, and that are suspended in a liquid, solid, or gas. I know that's a long definition, but what it really means is the particles are not heavy enough to settle out. Okay? They would, but they're just not quite. They're not perfectly homogeneous like a solution, but they're just not heavy enough to settle out. So your examples here are milk, mayonnaise, and Jell-O. What I want you to do now is take that blank piece of paper, okay? Pause this, and I want you to come up with 3 different types of suspensions. Think about your daily life, okay? Where have you seen suspensions? You can think on a small scale, or you can think on a big scale. Now, after you've done that, okay, I want you to take out your homework and start working on it. If you finish with your homework, then move on to another subject and you can work on work there. Don't be afraid to go back and replay this if you need to hear it over again. I'll see you guys next class and get ready for a lab.